Hello, this is video number 15, sort of a continuation of 14, where we were looking at the 2's complement number system for representing numbers. What we didn't do, or what I didn't do, it's all on me, huh? What we didn't do was try this out with some numbers, some math, and see what we get. So I'm going to do at least a couple of examples here. And let's try positive 27, and we'll add that to negative 9. I'm going to get myself in trouble again just making up numbers like that, but we'll give it a shot. What does this look like in binary if we're using 2's complement? The number representation system that does support arithmetic and does ideally get the right answer when we try to do math. I'm not even going to predict what that ought to be, but let's see what we got here. 27. Here's an easy fun thing. It's about time for an easy fun thing, isn't it? If it's a positive number, it looks like the good old-fashioned binary we've been using so far this entire module. So positive 27, there's no magic to that. To get positive 27, I'll put a 0 in 128, 0, 64, 0, 32, a 16, scratch work. I'm going to erase this. 27 minus 16, that's 11. Man, everywhere I turn I get stuff that looks like it's binary, but it's not. That's 11. 11, I can get an 8 out of there. 8, 9, 10, 11. 3, there's no 4s, there is a 2, there is a 1. That was the scratch work. It's gone now. Is that positive 27? Let me double add and see. Double check and see. 8 plus 2 is 10. 20. That doesn't look like 27. What did I say? 8 plus 2, that's 10. Oh, I added a 4. There is no 4 there. 10 plus 16 is 26. Plus 1 is 27. I'm stumbling over my own incompetence. That's what we have computers for, to do the math for us. This one's a little trickier. Negative 9, here's the deal. To find out what negative 9 is in 2's complement, I first have to get positive 9. Maybe I'll have less trouble with that. Positive 9 looks like this. No 128s, 0, 0, 0, a 1 in 8's place, and that leaves only one more. So I can put zeros here and fill in there. That's positive 9. That's still not negative 9. Negative 9, I start with the positive 9, 0, 0, 0, 0, 1, 0, 0, 1, do the flip, 1, 1, 1, 1, 0, 1, 1, 0, add 1, plus 0, 0, 0, 0, 0, 0, 0, 1. Finally and mercifully, I get a problem that's easy. Let's see. Maybe I won't mess this up. I'm only adding these bottom two here. You know what? I'll draw a line there. I flipped to get the top number, and then I add 1 to whatever I got after I did the flip. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 0, 1, 1, 1, 1. It just doesn't look like that could be real. If I did it correctly, if I flipped and added 1, then this should be negative 9. All of that was scratch work to get me ready to do this problem right here. This says add 27 27 is 0, 0, 0, 1 and 1, 0, 1, 1. All these colors decided to dry up all at the same time. It's just not my day. That's better. There's positive 27. I'll label it as such. Here's negative 9. That's the one that caused us all the pain and suffering. To get the negative 9, remember we start with positive 9, flip the bits, add 1, and there we are. It should be this. 1, 1, 1, 1, 0, 1, 1, 1. Negative 9. My, oh my, oh my. 1 plus 1, that's 2, but I put a 0, carry a 1. 1 plus 1 plus 1 is 3, I put a 1, carry a 1. 1 plus 0 plus 1 is 2, put a 0, carry a 1. 1 plus 1 is 2, put a 0, carry a 1. 1 plus 1 plus 1 is 3. Put a 1, carry a 1. 1 plus 1 is 2, 0, carry a 1. 1 plus 1, 2, 0, carry a 1. 1 plus 1 is 2, 0, carry a 1. And I won't even draw it over here. It falls off the edge. Now, that's what I got. We'll see what happens. That's what I got when I added the bit pattern for positive 27, which looks the same as plain old binary, and negative 9. The weirdo flip the bits and add 1 bit pattern we get in 2's complement when we want the negative number. So this will be place value chart. This will be 0, 0, 0, 1, 0, 0, 1, 0. I might even be able to add those up in my head if there's anything left in my head to do the addition. What is that? Well, that's a 16 plus a 2. 16, 17, 18. So this, in fact, is positive 18. How do I know it's positive? Starts with a 0. Now, take a mental snapshot of that or write it down or whatever, because I'm about to erase that and try a different one. Challenge for me. Let me see if I can get through the whole thing without flubbing it up. I don't know. That's going to be a close call. What about positive 7 and negative 20? Let's add those up. Positive 7 plus negative 20. Here we go again. Place value chart. Positive 7. 0, 0, 0, 0, 0, 4, and 3 more. 4, 5, 6, 7. There's positive 7. Negative 20. Not so simple. Positive 20 is what we have to start with. We have to find out what this number looks like when it's not underground. Plain 20 is 0, 0, 0, 16, 0, 17, 18, 19, 20. So there we are. There's positive 20. I hope. But we don't want no positive 20. We want negative 20. That's where we got to use the flip the bits and add 1 to get the negative version. So I'll start by copying the positive 20 over here in my scratch work area. 0, 0, 0, 1, 0, 1, 0, 0. Flip. 1, 1, 1, 0, 1, 0, 1, 1. There. That's the flip version. And I drew a line because the addition is going to happen below that line. I might not have made that clear before. Actually, there might not be anything at all that I've made clear today. But let's see if I can make this part clear. Add 1. 0, 0, 0, 0, 0, 0, 0, 1. That's step 2. Add 1. 1 plus 1 is 0. Carry a 1. 1 plus 1 is 0. It's actually 2, but I'm saying put a 0. Carry a 1. 1 plus 0 is 1. So there's nothing else to carry all the rest of this. 1 plus 0 is 1. 0 plus 0. 1 plus 0. 1 plus 0. 1 plus 0. Well, at least it's negative, thank goodness. I ended up with a bit pattern that would be viewed as a negative number on this 8-bit machine because it starts with a 1. So let's say that I did this correctly and cross our fingers. So this would be negative 20. That's scratch work. This is the real problem. Let's see if we can do the math. Positive 7 is 0, 0, 0, 0, 0, 1, 1, 1. Negative 20, that's positive 20. I don't want that. Negative 20 is what I get after I did the flip bits and add 1. That's 1, 1, 1, 0, 1, 1, 0, 0. There's a lot of ifs up in the air here. Let's see what happens. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 2, but I put a 0, carry a 1. 1 plus 1 is 2, put a 0, carry a 1. 1 plus 0 is 1. And there's no carry. So this will be 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 1 is 1. And there's nothing to carry off the edge. This is scratching now. It's in the way, so I'll get rid of it. Now, is that the right answer? Who knows? This is a mess. Well, it starts with 1, which means If we're working in 2's complement, this doesn't make any sense on a place value chart. We don't know what this is. We can't slap this up here and add up all the place values. No, no, no. We know it's a negative number, which means we got to find its positive additive inverse to find out what this is the negative of. Let me say that again. We know this is a negative number because it starts with 1, and we know we're using the 2's complement number system. To find out what this really is, we've got to flip the bits and add 1 to find out what its positive additive inverse is. So I'm going to say, question mark, what are you? Who do you think you are? 1, 1, 1, 1, 0, 0, 1, 1. Well, they know who they are, but we don't know who they are. So we've got to find the additive inverse. Step 1 is the flip. 0, 0, 0, 0. 1, 1, 0, 0. I'm going to draw the line again. Because now that I've flipped, now I've got to do an addition problem. Plus 1, that's step 2. Add 1. 0, 0, 0, 0. 0, 0, 0, 1. 1 plus 0 is 1. That was easy. 0 plus 0 is 0. The rest of it's easy. 1 plus 0 is 1. 1 plus 0 is 1. And zeros all around. What do I have? What I have, in the grand scheme of things, is the number that I have to add to whatever the heck this is to get back to 0. I have a positive number that I need to add to this to get back to 0, which tells me, if I find out, just pulling it out of a hat, if I find out that this is positive 127, then that means I must have started with negative 127. Because I know flipping the bits and adding 1 is always going to give me the additive inverse. It's always going to give me what I have to add to what I started with to get back around to 0. Now, I can slap this on the place value chart because it's positive. 0, 0, 0, 0, 1, 1, 0, 1. See if I can add that up in my head. Who knows? 8 plus 4 is 12, plus 1 more is 13. So it looks like that's positive 13. Positive 13. If that's the case, then this must have started off as negative 13 before I did all the stuff to it. Look at that. Did I look at? I think I did. Positive 7 plus negative 20. The signs are not the same, so I'll have to subtract 7 from 20, and it is, in fact, negative 13. Whew! I think I'm going to quit while I'm ahead, if I am ahead. Maybe I'm quitting before I get further behind. This would be an excellent topic to bring up during office hours or during our regular class meeting this week or via email, whatever. Let me know if you need to look at some more examples of this. But I'm going to hope that that's enough to get you rolling. I'll see you online.